Okay, the first one, let me get a pen. The first one is this, né? Is that if I have x to the power n multiplied by x to the power m, I'm going to basically, you see here we have the same exponent. We have x here. I mean, you have the same base. You have the x here, you have the x there. So you keep 1x, and then because you are multiplying, you have to add the exponents. So the rule is when you multiply the same bases, you have to add the exponents. Okay. And then the opposite of this rule is this one, which is the second one. I have x to the power n over x to the power of m. In this case, I still keep the same base because I have the same base, which is x, and then I have to minus the exponents now because I'm dividing. So when you divide, you keep the same base and then you minus the exponents. Okay. Then now let's do rule number 3. So the third law is saying if I have x to the power of n over x to the power of m, and then I have another exponent outside, let's call that exponent a. The rule says this. It says the outside exponent must multiply with the inside exponents, all inside exponents. Ne? It must multiply with all inside exponents. So we're going to have x to the power n times a, which is an, right? All over x to the power a times m, which is am. Do you see it? And then that is how you remove the brackets in exponential expressions. You multiply all the exponents inside the brackets with the outside exponent. And you can see that this now applies to that rule there. Do you see it? You can now minus the exponents if you want to. Perfect. And then number 4 is the same thing, but with multiply. I have x to the n dot x to the m with to the power of a. I'm going to multiply that and that to a. So n times a, it's an. So I'm going to have x to the power an dot x to the power am, right? And then from here, you can see that I can apply that rule because I have the same basis. I can decide to say x to the power an plus am, which is adding the same basis. I mean, you are adding the exponents if you have the same basis. You see, also here on 3, I could have just said, okay, I have x, I have x. I could have said 1x, and then here I have an, here I have minus am, right? Perfect. And then rule number 5 says anything, no matter how many letters I have here, I can say to the power 2, to the power 3, to the power 1. If it's to the power 0 outside, the answer is 1. So it says any base raised to the power of 0, the answer will be 1. That is what the rule 5 say, right? And ladies and gents, please note, you do not need to know these rules in order. There's no specific order you need to list them. The most important thing is to know all of them. The order does not matter. Okay. Perfect. And then the other rule is this. If I have x to the power negative n, I can write it as this. Just check it. You always want to leave your exponents as positive. Now you have a negative exponent there. And you can see that the x is now a what? It's a numerator. To change the sign on the exponent, you have to make now x the denominator. So the x will come at the bottom. Then the sign here will switch. And then here you're just left with 1. Do you see it? So you always leave your answers as positive exponents. And then the last one, last but least, you have n square root of a. Let's say to the power m, right? This rule says this. It says you can always convert the rule to the root, to this. Inside you have a to the power m, and then you put a bracket. This n here can be written as 1 over n. Do you get it? It's always 1 over whatever the root is. If you have a square root, you are going to have 1 over 2. If it's a cube root, you have 1 over 3, and so on. And then from there, you can see that you can apply this rule or this one. You can multiply this, and that is going to be a to the power m over n. Right. And those are the 7 most laws of exponents that we're going to apply throughout our study of exponents. Please, ladies and gents, learn them and know them off by heart. Okay, perfect. So now I'm going to erase this portion. I'm going to erase all this portion.